Assalamualaikum warahmatullahi wabarakatuh and have a very good day to everyone. Today we will continue our lesson to subtopic 1.4 Elasticity. So in this subtopic we will learn about one of the force which is related to spring, a man-made ingredient which can be compressed or extend when a force is applied. The physicist who introduced the study of spring is Robert Hooke. So what is Hooke's law all about? Hooke's law states that the extension of the spring is directly proportional to the force applied, as long as the elastic limit of the spring is not exceeded. Mathematically, X, which is the extension of the spring, is directly proportional to F, or F is directly proportional to X. Mathematically, F is equal to Kx. K is the spring constant in Newton per meter and X is the displacement of the spring from its equilibrium position. So first, what is extension of the spring X? So we have a diagram here. This is the original length of the spring without the force, and when there is a force applied, the spring will extend to certain length. So this is the original length of the spring and this is the new length of the spring when force is applied, and X is the extension, meaning here X equal to L, which is the length of the spring when the spring is given a force, and minus original length of the spring. So that is X. So what about K? K is the spring constant which represent how stiff the spring is. Stiffer or more difficult to stretch spring have higher spring constants K. Now more on spring constants K. There are 8 springs on the slide and they are grouped into 4 groups to compare their elasticity and spring constant respectively. So we have the first group, which is steel spring and copper spring. They are different in the types of material, but they have the same diameter and the same thickness and also the same length. So we see that the elasticity of steel is higher than copper, while the spring constant of copper is higher than steel. So by this relationship, we know that the elasticity and spring constant of a spring is inversely proportional. So for the spring which has higher spring constant, such as copper, they need more force in order to extend it to a larger extension. Compared to the steel, steel is more elastic, thus steel need less force in order to stretch it. And a second comparison, we want to compare the diameter of a spring. So they are the same material, steel spring with larger diameter, and the second one is with smaller diameter. The smaller diameter has higher spring constant compared to higher diameter spring. So a spring with smaller diameter, they need more force to stretch them to a higher extension. So I do not note here about elasticity. So you must understand that elasticity and spring constant, they are inversely proportional. So that is the relationship between elasticity and spring constant. So you need to remember only one characteristic so that you can compare later. Next, we want to compare the thickness of the spring. So we have the same length, same material, but different thickness. The spring with larger spring constant is the spring which is thicker than the fine spring. So the thicker spring, they have a larger spring constant. It means that thicker spring, they are harder, so they need more force to stretch them. And the last comparison, so we have a different length of spring, shorter and longer, but they are the same material and same diameter. So shorter spring are harder to stretch, thus it has higher spring constant. Next, we will learn about the graph of force against displacement. So we have the graph here. This is the force in Newton and extension of the spring in centimeter. Hooke's law states that X is directly proportional to F as long as the elastic limit of the spring is not exceeded. So what is elastic limit? If greater force is applied to the spring more than its elastic limit, then the spring will be inelastic. So the spring will not return to its original shape. So again, what is elastic limit? Elastic limit is the maximum force which can be given to a spring so that the spring can return to its original shape or position. If a higher force than elastic limit is given to a spring, then the spring will not return to its original shape. Get it? Next, gradient of the graph M equal to F over X. From Hooke's law, spring constant K equal to F over X. Thus, gradient of the graph equal to spring constant. So we have the gradient of the graph here, and the gradient of the graph represent the spring constant. So that is the second information from graph of F against X. Now, area under the graph equal to half Fx. So the shape of triangle here is the area under the graph and it represents energy. How do we know that it represents energy? It is by the physics unit of the triangle. So F is in Newton and X is in meter. So the unit is Newton meter. So we know that Newton meter is the unit of energy. Thus, area under graph F against X equal to elastic potential energy. And from the graph of F against X also, we can derive the work done by the spring. Work done by the spring is half Fx. Remember that force equal to Kx. Thus, we substitute Kx into K. So, W equal to half Kx times X. Thus, work equal to half Kx squared. As a conclusion, the informations from the graph of X against X is number 1, elastic limit. Number 2, the gradient of the graph equal to spring constant, K. Number 3, area under the graph F against X equal to elastic potential energy. And lastly, work done by the spring W equal to half Kx squared. So those are informations that we can get from graph of force against extension X. That's all for now. Thank you for being with me. I am Nofazila Yusof and you can go to cikgufazila.blogspot.com for more information. Bye. Assalamualaikum.